organizers of this asked me to send a reading list, which I also did. And I tried to give an exhaustive set of readings, which are not just from IS, but sort of across the board, because, some of you may be familiar with a couple of years ago, a few of us wrote an editorial on generative AI for ISR. And I think 2 years is almost like 100 years in the era of AI because of so many advances. It's really dizzying to keep up with what's going on. We ourselves, as senior professors, are constantly having to learn new things every day. Without scaring people, I want to also convey both, I hope, both the goods and bad. And what are some responsible conduct of research in the era of generative AI? Given that this is also finally, it's kind of a stochastic prediction model, a lot of generative AI models. So let me talk about some of these. Um, First, this is a paper that was published in a journal called Economics Letters, which is fairly well-regarded journal by a fairly reputed economist, Joshua Gans, who is also author of this book called Prediction Machines, some with co-authored with a couple of very interesting book about AI. You know what's very unique about this? Can anyone take a guess why I put this on my slide, very introductory slide? This paper was written entirely by generative AI, and he disclosed it. Joshua Gans wrote a paper in like 2 hours with generative AI, submitted to a journal, disclosed that it's written, and it got published in a reputed journal. So this is the world we live in. Reviewers can use generative AI. I'm not sure I'm supposed to say this like officially, but people are using generative AI. Authors are using generative AI. We are using generative AI as a substitute for human interaction, human behavior. All sorts of things are going on, right? Some undesirable effects, some incredible productivity improvements. So what is it that I can talk about generative AI to you guys? So this is kind of the outline of this tutorial. First, I'll just give a brief introduction to these large language models and talk about prompt engineering, a little segue into AI agents, not too much time in this short format. I will talk about how to use generative AI as an aid in research with a few examples from my own research. We have to be very aware of the biases when we use generative AI. So I will talk about those biases issues and some of these best practices. This is a very ambitious agenda for a short like session. So I will provide some of these slides, especially the best practices in Gen AI. I'll just kind of use an appendix and some things for us to think about and know about. Right. So what are large language models? Most of you know what these are, but we'll just start from scratch. So most of us know about Google autocomplete, for instance. Stanford University is located in. If you type in Google, it will supply the answer. From there to ChatGPT, what kind of happened, right? ChatGPT is like autocomplete. In theory, it is possible for us to type like an entire text of a detective novel into, say, ChatGPT or some other, generative AI model, and ChatGPT should ideally return one sentence, and the murderer is, right? That's kind of how these are. We have not programmed these large AI models with any intentionality, but the way they are trained with the kind of state of the art training methods and the fact that they're trained on massive amounts of data makes them very good at kind of predicting these associations, right? And that's kind of what large language models are trained to do. Look at GPT-3 training data. This example is already many years old. It's like you kind of scrape the web. Training data can include anything. It can be Reddit posts, it can be somebody's essays on college application essay to all sorts of things, right? Uh, those movie IMDb kind of quotes, Wikipedia. We take this huge amounts of data, not we, the commercial companies such as OpenAI have taken large amounts of data, stripped it uh, into tokens, and these huge tokens with like 400 billion, you train it using state of the art uh, models called the architecture that makes it possible is called transformer architecture. So this paper called Attention is All You Need. This is what I guess made ChatGPT possible, published by some researchers in uh, Google Research. And this was published in, I think, 2017, if I'm not mistaken. You can Google it. So 8 years, 8 years, and it's like, you know, the the proverbial the meteor that hit the earth, and I guess many industries are now scrambling to sort of find their response, right? It's a specific kind of network architecture. And what is powerful is attention mechanism is a type of, I would say it's when you're training these large samples of corpuses of text, attention mechanism trains us to look for words in the context of their surrounding words. But there's also kind of longer term attention. So if you're reading a detective novel, think about it like you're reading a novel and you're looking at, oh, this is this is like an interesting character and he has these traits. And 100 pages later, we can come back to what we read in page 3. Attention mechanism works a little bit like that. There's like these kind of long-term textual dependencies in how we are kind of training these models to recognize associations, right? So approximate timeline, there was a time when we used to use these word embedding models. I don't know anyone here in the audience is familiar with word to vec type of methods. So word to vec is basically what we have with these embedding models is a vector space representation, right? We've taken these huge textual corpus and we are representing it with a billionth, a vector with like billions of dimensions, if you will. It's hard for us to visualize, obviously, which is why these models are kind of black box, hard to explain the working, right? But then from there on, we got these different methods of learning and we have powerful architecture. And then we have what is called pre-training. And from there, we've gone to prompting, right? So what we now have is a sort of, you could almost call them foundation models. They're trained on very general purpose tasks. So models, whether it's ChatGPT or OpenAI, the Anthropic's Claude, or their DeepSeek now, which is uses this their engine is called R1. All of these are basically not only they're very good at predicting or good at maybe generating associations, since they've been trained on large amounts of data, some people might say they're almost functioning as substitutes for human beings in the sense that since so much human output went into creating these models and then they're kind of predicting all these associations, can you use ChatGPT as, very much like I used to be a researcher of social media. You can do social media analytics and study what people are saying on social media about various things, whether politics, it can be environment, it can be brand communication, traditional business school type of subjects, right? So maybe we could do the same with some of the large language models, right? So it's kind of the stylized representation. And what do language models do? Maybe it's providing us with some rudimentary way to model agents' beliefs, right? It can be actions, right? So there's, again, I don't want to describe, it's just artifact. I don't want to describe intentionality to it, but we can use it to simulate like human behavior. And to that extent, it's very helpful in research, right? So what used to if we want to think of the history of I would say that earlier we had very specialized hardware built for tasks. Now, what we have, the hottest programming language, according to some people, is actually English because we are interacting with ChatGPT type of models with natural language query, right? And that sort of why is that interesting? It is interesting because in some sense, if I used to work as IT consultant a long time ago, and I remember that you had this kind of specialized pipeline. If a decision maker in an organization has a question, or what were some sales, or what are some trends, or what is something else, you can't just go and question it directly. All the data resides in multiple systems. You have to kind of pull all those data together. You have to build that kind of pipeline that interoperable, and you need a specialist that can put all that data together, translate it into what it means into a context that business decision maker understands. Now, presumably, I'm not saying it's effortless. One could just ask that question in plain English and get an answer, right? So it's very interesting at multiple levels. It's interesting about how it changes things within organizations. It's interesting in terms of, I guess, the decentralized structure of information processing. It's also interesting, like I said, uh, it can be a way to measure sort of you know human attitudes and human behavior. So I would suggest that if we how do we work now with this powerful generative AI tools? There are prompt engineering overviews by Anthropic. Anthropic is like my favorite. Uh, Claude is my favorite engine. I use Claude sometimes to just as like a brainstorming sort of a thing. I don't like to use, I just talk about generative AI. I have some research where I use generative AI models, but I like to write. I don't like to put my writings through ChatGPT, full disclosure. I don't like to use generative AI to help me write a paper because I'm very old-fashioned scholar in that sense. But it's still very useful to think of best practices. And I think both Hugging Face and Anthropic have excellent resources that I would suggest will be helpful for you guys, right? So the insight is based on something called zero-shot learning, which is basically you can do these models the way they've been trained. You can do a lot of tasks without additional training. I will give an example. Has anyone here used BERT or any of those vector space embedding models, word to vec, BERT, etc.? I'm seeing some nods. If it's BERT, you need to do pre-training for BERT, right? You take BERT, if you might use FinBERT or FineBERT as it's called for financial statement analysis, but for specific context, for environmental regulations, if you want to do BERT with ESG, I think some people have fine-tuned and developed, but you'll have to do additional fine-tuning. Whereas ChatGPT, in theory, you don't need many other examples. So where was Tom Brady born, right? Or can you compare probabilities of sequences? The cat couldn't fit into the hat because it was too big. So you can ask some preliminary like probability comparisons and so on. So that's called zero shot learning. Similarly, you can have zero shot prompting. For example, you can say write a poem, translate something into French, right? What is the problem with that? Well, sometimes there will be hallucinations, or sometimes it will give you an output. But is that really helpful? Do you need additional fine tuning, or do you need to experiment to find the right prompts? How do we find these right prompts, right? So this is why I feel that when people say I asked, a lot of times I'll see my colleagues, they'll say, oh, I asked AI, I am using AI in my teaching. How did you use it? Is there best practice? Did you ensure that these outputs are actually reliable? Is there a set of, did you document how you asked AI? Did you compare different uh, you know different models, different large language models, and do some kind of and what about prompt quality? Is there are we adopting some good practices that tell us what is good prompt quality? How do we measure it, right? So I think some basic understanding of large language models as very large vector space representation is just helpful for us to visualize them in those terms, because that will help us devise the right kind of prompting techniques. That's what I would say, right? So sometimes, for instance, you have few shot prompting. So you present a model with a task or question along with some examples. And what is happening here? Effectively, you're nudging or training the model to perform some specific tasks with minimal training data. So in other words, since the since this model has already been trained on a lot of data, for my purpose, can I fine tune it without too much effort, right? So it's like constraining my model to produce more accurate, consistent outputs, right? Most of us, I think when we were in our graduate seminars, we've taken classes in, how to do experiments or how to do empirical work. And it's almost that we are at a stage where we need some kind of best practices, because we are using these large language models one way or the other. How do we make sure that this is auditable? Whatever we are doing, we are self-imposing some rules and putting some best practices on them, right? So do you need fine-tuning or experimentation to find effective prompts and examples? I'm also a big believer in kind of sometimes maybe a bit of A/B testing would be helpful, like take a pilot set of examples and see how it performs in specific tasks and do some A/B testing before you deploy it into, a research study. Very much like how you do pilot tests, for like how do you pre-test questionnaires? I think we need some practices around pre-training models, just like you do pre-tests if you do questionnaire-based research, right? Oh, okay, 1 second, sorry. What's going on? Yeah. So the other times, the few shot learning is also sometimes called in context learning. So how do you essentially what is happening is we are kind of giving a few examples of the task before your examples. So you're sort of there's also, I mean, there's like these are kind of two different things, and this I'll skip the technical details, but one example is you give a few examples to make the generative AI model learn what is it that you want. The other is provide some context. You could do both. That's what I would say as well. So how do you do like standard prompting? For example, there's the best practice in like the computer science folks will tell you is what is called chain of thought prompting. Chain of thought prompting is basically you give model input and then you try to give a question and answer, and then you ask the next question. So essentially it's like a following a chain of thought, right? And you don't have to take my word for it. Like I said, the Anthropic Prompting Guide has some best practices. You can look for more examples there, right? I didn't want to make this session all about prompting, so I just, there's some nice studies as well, right? Essentially, what's happening in this chain of thought prompting is you already are taking this large language models trained on so much data, and you're trying to fill in this missing common sense kind of information, right? 1 second. I'm having some slight problems with my video. Let me just share my screen again. There, sorry. Right? So this is basically what is going on. So, of course, the other is you can use AI to generate prompts. Some studies say that use one AI, generate prompts, and then use that as an input in another AI. But of course, it's important to audit those inputs and audit the prompts, but that is also another way to do prompting, right? Now, what is the danger with all this? Do you know that the outputs are actually reliable? So the best practice is called RAG right now, retrieval augmented generation, which is basically a way to compare your query output with like some kind of a fact checking, if you will. How do you fact check 100,000 maybe records or maybe million records that you've retrieved from ChatGPT? Not that as researchers we are doing, but in industry when people use ChatGPT and other generative AI models, what are they doing? The standard thing is to basically compare it with some vector database output. And with my master's classes, when we do industry projects, what we do is we use like there's FAISS, which is a vector database provided by Meta. It's open source. So we found it helpful to use, we can use a model context protocol and build in a RAG layer. And that's slightly technical, so I'll skip all the technical details. But very minimum, it's important to make sure your outputs of the generative AI model is not just making up something. The word for it is hallucination. And how do hallucinations happen? Well, since generative AI is basically kind of a very large scale pattern matching or pattern prediction exercise, right? It is very helpful if it helps us automate some aspects of our tasks, but there is no guarantee that all the outputs are going to be correct and factually sort of something that I can use. So it's important to have that extra caution, ensure that you are, outputs of these models are not hallucinating. Of course, there's other ways of, suppose you want to do a literature review using generative AI and you restrict your attention to maybe the literature that is within, let's say, from it comes within the IS discipline published in IS journals, right? And those kind of things, I think there is some level of, by definition, are less likely to hallucinate because we are the data that we are working with is kind of, we have a little bit more of a, we can control the reasoning process or input, right? But nonetheless, it's important to have a layer of verification and so forth. So let me start with one or two examples that I've seen in recently published work. So this is paper that's just forthcoming in Marketing Science. And what I thought was interesting about this, it's very much like a data science or design science approach, right? But what they've done here is in marketing, there are a lot of A/B testing uh, of how to make, right, how to make things more engaging to, like, say, end users. And what did these researchers do? They basically compared large language model like OpenAI. They also used Llama, which is open source large language model developed by Meta Corporation. And then they compared it with standard vector embedding methods like a BERT type model. And essentially what they've done is, so, can you do a zero shot prompting, right? Or can you do a chain of thought prompting? And can you compare it with just the embedding based approach, right? So can you provide a in context type of learning? All the examples I mentioned earlier, you can do few shot, you can do in context learning. Can you design a better prompt using all these examples, right? And of course, the abstract just tells you essentially their fine-tuned prompting strategy was outperforming standard A/B tests, which is not surprising because there's like huge amount of training data that went into these experiments. I spent some time thinking about how can this help an IS researcher. In marketing, they do a lot of A/B testing. I would say again in IS research, I think understanding prompting strategy and what makes a prompting relevant may be helpful for people who study platforms. Prompting strategies can be helpful maybe in terms of If you're doing some of the work where we study human AI collaboration, for instance, that is like another area where getting these right prompts and understanding what is the how prompts can be better designed, effective, and so forth. I think I may have included in the readings. There's a recent paper that came out in Organization Science, I think Karim Lakhani and co-authors, that has very good way of evaluating prompts as well. I would suggest that as another paper to look at if you're interested in how to get better prompting strategies. So this paper I think is interesting more because of just the authors have taken a little bit more intuition into prompting, and that is kind of helpful for us in maybe the IS community. The lot of hype now is in these AI agents, which is kind of you can write AI to be sequentially programmed. It can sequentially perform tasks. So, for example, right, the AI agent you can write an AI agent, which is essentially not just searching the large language models, but the you can also have AI. The large language model can also generate code for you. For example, Claude Code. Claude has a code generation, which is doing pretty good. I think, as far as I've seen, I think it outperforms the other, like there's Cursor and Windsurf, which are so-called vibe coding, if anyone has not heard of those. So AI agentic AI is basically one where you have the AI models are equipped with a little bit of additional, they can go out and write code and they can do sequential task processing for you. So it's almost like I can instruct the AI, okay, search the web, summarize results, do some comparison checking, put some reasoning, and then, buy me this dress if it satisfies like a certain set of like criteria, and without any additional coding, so to speak, right? So there is a lot of industry hype about AI agents, but what is it that, again, for us in IS community, why should we care about it? Because this is really pure digital transformation as it's happening without too much of additional supervision by human being. So of course, there are a lot of organizational implications, right? Me and a couple of my colleagues are running a special issue on agentic AI for ACM transactions and management information systems. The papers are due in the fall, but thought we should just put in a pitch here. So, what happens when you have workflows enabled by AI? That raises a whole set of issues which I don't have time to go into. But I think that how can you ask a AI agent to make your research process more effective? Well, for example, I use this for a class, right? Can I get an agent-based workflow along with RAG is retrieval augmented generation for financial statement analysis? So this is what Claude generated. And I can have this workflow along with Claude. So think of it following way. If anyone here in this audience has taken a class on financial statement analysis, what is financial statement analysis? You do all these financial ratios, and you have to analyze like the company statements for like soundness of the financial the cash flows and the operating balances and what have you. Now, without knowing anything about financial statements, I can go to Claude and ask me, just give me an agent-based workflow. So then I can generate code and I could just basically walk away, right? In half an hour, ideally, I can put through a lot of financial statements, provided this code is like reasonably solid. It can work with other, I can just write that kind of a pipeline where I can read a lot of financial statements and get automated reports. Does this sound interesting to anyone? Well, maybe financial statement analysis is not your thing. But again, if you're an IS researcher, you can use the same pipeline, agent-based workflow, to automate how you collect maybe social media data, to automate how you collect data from, say, things like Reddit, to automate data from Yelp and online reviews, customer review sites. I mean, a lot of different applications. Automate also analysis of, anyone here has done data of analysis of patent data, or maybe data from financial statements of companies like 10K. Long time ago, I used to be an archival researcher. I did a lot of studies of contracts, which we used to hard code. One of the, if I look back now, some of my papers that were published in journals like ISR and MISQ, I had 150 data points, right? And I did surveys. I also used data from 10K filings of companies, created sample, created uh, everything was like hand collected, hand coded. For inter-rater reliability, we had two people coding and check the consistency. Now just imagine, I don't need to do any of that. I can cut short that whole process, get these 10K filings, and just basically instruct my AI agent, and it'll do it much more efficiently, much faster, and it will take a fraction of the time it took me. And if I want internal consistency, I can have data from two different large language models and have a third agent compare the two different large language models. Is everyone following my thought? Right? So it's definitely more efficient. And I also have to say, as someone who's been around in this research field for a while, it also makes me wonder, like, what do we do with our prior research methods? I mean, I don't want to say that, you know, the the insight I had from the older papers is not relevant, but it's definitely the methodological, the tools I have at my disposal now as a researcher are a lot more powerful than what I could have possibly imagined 10 years ago, right? And that's wonderful, but that may be also sobering. However, that may be the case. 10 years ago, this is just unimaginable, right? You have, just imagine the same process applied to 10K filings or ESG disclosures of companies or lots and lots of large scale company data. And that's the power of generative AI, right? So this is what sample agent workflow that Claude generated. You can do profitability analysis, liquidity analysis, and so forth. So given this awesome power of generative AI, how do I use it as an aid in research, right? Um, So I guess we could do, this was very interesting. A couple of computer science professors, they're very, Arvind Narayan, and I like his posts on LinkedIn and I like to follow, and his tweets are also pretty good. So one of the things they were talking about is, well, now that we have all this awesome power, we can use it for idea generation, we can use it for evaluating research, we can use it for detecting error, we can use it for literature review, although with caution, obviously, right? And maybe new uses. So I will share a few examples now, right? This was a very, I'll just leave it for those interested to read this paper. Can generative AI improve social science? Chris Vale, who's sociologist, very, very thoughtful sort of paper, right? So how should the advancement of large language models affect the practice of science? That's also very interesting sort of right. This is probably, sorry, I'm having a lot of problems with my share. I'll stop sharing and share again. This is probably the most interesting for all of you guys in this audience. The Genskow and others, Textus data is just introduction to just textual data, but there is this very good research survey by Korinek. And what's very interesting is in this paper, it's like a living document. It was published, but he keeps updating it on his website. So I would suggest going to Anton Koronek's website. Application of LLM for ideation, writing, background research, data analysis, lots of very, very interesting sort of things. And there's like users, this is also very good. And of course, a lot of prompting examples that I've already talked about, right? So this was the Kornek paper I talked about, which he keeps updating it. And it's really, really interesting. This is a working paper. What they've tried to do is like evaluating large language models on economics reasoning. I guess one can think about this for psychology type of research, for survey research, and so forth, right? Another very interesting example, there's a economist, Senthil Mulanathan, who's I think at University of Chicago. He has done some fantastic work using multiple methods. In this paper, uh, the 2025 working paper, they have very interesting examples of how you can use large language model for basically difficult to elicit constructs. For example, right, congressional legislation, right? Uh, the text piece will have a description of bills. Can we use generative AI to do better textual proxies of like what the politician's intent is? And they have some nice examples from there, right? And so can we capture intuition that is hard to capture with generative AI models? Those are, this is again very fascinating. John List, who he has a whole lot of set where you can use generative AI to do a lot of experiments. So just like I mentioned, right, the AI agentic AI framework, you can have AI agents acting as real people and design experiment. And this is just fascinating, the possibilities that one can think of, right, with all these. Um, can AI replace human subjects? This was really interesting because what these guys did was they looked at a 10-year period. Uh, some of you recognize these journals, all good management journals, OB, HTP, AMJ, right? There's like some other psychology journals and so on. I mean, I have colleagues who publish in these journals. So what they've done is they've basically taken a lot of scenario-based experiments published in over 10 years in 5 management journals. Said, can I replicate this with generative AI without using human subjects? They were able to do a very good job replication, TLDR, right? Let me just, so I hope this is convincing to you guys that these generative AI models have a lot of power in transforming research as we do it now. Like I said, I think about some of the old stuff I did with contracting and with sort of understanding the theory of the firm. And those were smaller sample studies. Now, can I do it much larger scale, but more harder to quantify variables using a lot of different textual sources, right? I could use 10K documents, but I can also get whole lot of other things that I did not have access to in 10 years ago or something like that. Board game of diplomacy. Some folks did this like an agentic based. So can you use AI for negotiation games? There's a lot of scholars and organization do these studies on negotiations and so forth. Can you use AI to replace? Well, some of it you can. This is more supply chain planning, and it's a very technical sort of thing. But again, supply chain planning in operations management literature, there is a lot of like optimization type research where people are kind of tend to be a bit of theoretical purists. They are like, I need to code my optimization model. Well, now large language models can take that 3 or 4 dimensional optimization and make it into 100 dimensional optimization problem. So that's another new frontier as well to scale. So I will give a few concrete examples from my research, right? So the LLM plus agent for construct definition. First, let me give a few toy examples. I think I'll just concentrate on just the first example. How can I do construct definition using large language models? And I think we are past the 45-minute time. So I'll maybe go until, right? Another 10 minutes, I'll give more examples and then we can take questions. Um, so I'll give some toy examples. First, can I use ChatGPT to do sentiment analysis? Yes. Just scrape some online reviews, right? Classify the text as positive, negative, neutral, and run aspect-based sentiment analysis. Is this zero-shot prompting, few-shot prompting? What kind of prompting is it? Are you paying attention in the earlier when I was talking about? Okay, it doesn't matter. You can go back and look at the slides. But essentially, this is just very naive chat GPT for sentiment analysis. Now you can take a piece of text, just scrape some reviews from Amazon, right? Or don't even have to scrape. Just this is just a conceptual exercise. What can I get using chat GPT? I don't need to use BERT. I can just use chat GPT as substitute for BERT. And what is the right way to do it? Well, then maybe I need to do a A/B test, do a BERT versus ChatGPT comparison, right? And what else can I do? I can also have my prompting strategy I can fine tune by doing zero shot prompt versus a few shot versus in context learning, right? Different kinds of prompt analysis, right? There's like what is called react prompting and so forth, right? Chain of thought. And so, will this help me? Of course, it will. For whatever I was using BERT, maybe I can use Claude or Llama, which is open source. You can run it on your laptop, right? Um, it will call for a few more skills, like you have to be comfortable doing. But then, if you were doing BERT-based models, you had to be comfortable doing some additional pipeline, Python-based skills, and so forth, right? So it may be very interesting to think about this kind of implementation. Similarly, this is a very toy network analysis example, right? Give me 20 pairs of most important characters in the book, Lord of Rings, with the weight of appearances, each entry. I can just take this and plot it into a graph, right? Can you do this with something else? Well, you can do this analysis for Harry Potter. You could do this analysis for, this movie Love Actually. It's very interesting from a network science perspective because the character arcs of how the characters are connected and the weight of appearances, it's like 3 or 4 different plot lines. So the network analysis actually shows how the plot is like sort of moving and so forth. I know that people have used to back when Game of Thrones was popular, people used to use network analysis to predict which character is going to die next and so forth. So it's just interesting exercise for I since I teach these in my data science class. But how does this help in research? Well, similar textual proxies can be found for like if you're for board of directors, for understanding board interlocks. Can I devise better measures using LLM based measures? Well, of course I can, right? And again, like I said, it's important to compare prompting strategies and have sort of, you know, be more audit yourself when you're doing these. So I'll give one concrete example from one of my own papers. So this paper published in MIS Quarterly some years ago, right? In that paper, what we try to do is, since there is a lot of healthcare information on social media platforms, right? What we try to do is, can we do a simple evaluation of all the videos that are about diabetes on YouTube? Can we get a large representative sample? And can we find a way to quantify, is there any medical terminology at all in these videos? Right? How do I quantify medical terminology? Well, there is you there is actually a syntax, universal, it's a universal medical language syntax developed by National Library of Medicine. So one thing we could do is you can have a dictionary based approach, right? And just measure the number of medical terms. We could do some other state of the art at that time was something called conditional random fields. You can do some Markovian measure. The third was a deep learning based approach. At that time, co-authors and I came up with, we'll do what is called a bidirectional long short-term memory model. What does BiLSTM do? This is basically running two long short-term memory models and simultaneously. So the deep learning method is where we have set of labels. We have experts, doctors, medical students, helped us annotate the data set, created training data with labels. And then we have to, it's a labeling classification problem. We can take it and use the deep learning method to identify medical terminology in videos. So it's kind of medical information is embedded as a medical entity and semantic relations, right, between entities. This is now what I can do with Claude Code, right? So just using AI agents and Claude Code, I can extract, this is all in theory, obviously. I can extract YouTube videos. I can extract the metadata from YouTube that I already have the pipeline to do, right? And then uh, Claude suggested that this is medical term. There's one agent that does context classification. One agent will do engagement analysis. One agent will do some medical terms analysis. And then I can automate this kind of a process. It doesn't work effortlessly. But what I did in that paper now can be done kind of more efficiently and with scale. And there's a lot of newer things I can do as well, right? So anyone doing any YouTube video analysis, you need in community, DID is very popular. So of course you need some good exogenous shock. But once you have a nice exogenous shock and you want to analyze some things on YouTube, well, you have agentic implementation to help you streamline that process of analyzing all this messy data, right? I hope that's just one way to, right? And this is not, we haven't used this in one of our research, in current research project, just the idea of what can be done. But we have, my team and I definitely used large language model, agentic implementation with large language models to extract like sort of medical terms. And it's just amazing how much quicker we were able to do stuff. The earlier generations of models, took us almost a year to build that model and sort of, train it and put it through the hoops kind of a thing. And for research, we're all constrained by resources. It's really interesting what all you can do with these generative AI models, right? And so just in terms of prompting, you can do structured prompt. You are an AI language model, right? Designed to classify user questions into predefined category. So can I classify the nature of why are people looking for information? Can I classify on YouTube? Can I classify it, right? Can we do chain of thought prompting to classify the information, medical information seeking on YouTube? Can I do few shot prompting, right? Can I do a comparison and see like which prompting strategy is better, right? And so, of course, there's different levels of autonomy. You can use AI agents as assistant, but be careful. They are not collaborators. They don't, doesn't quite work. And they're definitely not scientists, right? I think I'm kind of almost an hour. So we could do more of these human AI collaboration field experiments as well. We see a lot like using platforms like Prolific, we can build the architecture where we can develop constructs and then can be, you know, uh, then maybe we can implement experimentation platform through Qualtrics or Prolific or what have you. So I think I should stop here and see if people have questions.